Look closely at this image. Almost every point of light you see is an individual sun, and there are more than 60 million of them packed into this single frame. You are looking at the swarming center of the Milky Way. To photograph a star field this crowded at this level of detail would normally take thousands of hours. A European spacecraft captured this entire region in roughly 26 hours. This is the work of Euclid, a space telescope launched in 2023. Euclid was specifically engineered to look into the deep, empty darkness, to photograph faint galaxies and map the invisible dark matter between them. Its design is the exact opposite of what you need to photograph a crowded, blindingly bright star field. Aiming a machine built for the void directly at the brightest, most saturated part of our galaxy is an anomaly that requires a specific explanation. Despite having 60 million targets in sight, Euclid did not discover a single new planet in this image. That zero discovery rate was expected. In fact, it was the plan. This is a deliberate before picture, a record of the past, taken now for a telescope that will not need it for years. To understand why astronomers are setting this 60 million star trap for the future, we have to look at the invisible prey they are hunting. Most planet hunting techniques are biased toward large, hot worlds orbiting close to their stars. Those are simply the easiest shadows and heat signatures to detect. This leaves a massive gap in our knowledge, the cold, frozen worlds circling in the dark far from their suns. 20 years ago, astronomers found one such world, a planet so icy they nicknamed it Hoth, but they have never been able to measure its mass. There is only one way to weigh a world that sits that far in the deep freeze. It is a technique called microlensing. When a nearer star drifts before a distant one, its gravity acts like a magnifying glass, brightening the background light. If the foreground star has a planet, its gravity adds a tiny, lopsided tug. That extra flicker reveals a hidden world. Catching these fleeting random alignments is the only way to find planets hiding in the dark. The core problem with microlensing is that it relies on pure chance. To catch two stars lining up, you have to stare at the most crowded patch of sky possible to increase your odds. These alignments take weeks to unfold, but Euclid only looked at this region for one day. Observatories like Hubble take incredibly crisp images, but see the sky through a very narrow straw. Mapping this region would take thousands of hours, but Euclid's superpower is its wide-angle lens. It can capture enormous patches of sky in one shot, without the crowded stars blurring into a single smear of light. By snapping all 60 million stars in one clean shot, Euclid locked in their exact starting positions before any of them begin to overlap. The value of this image isn't in time spent watching. It is the creation of a flawless spatial map of millions of targets simultaneously. This map is for the Roman Space Telescope. Roman is specifically designed to watch this exact patch of sky for weeks at a time. When the Roman telescope eventually catches these chance alignments and planetary flickers, it will record how the light changes in real time. This diagram illustrates how the trap springs. Astronomers will reach back to this Euclid image as the absolute before reference. By comparing it to Roman's after data, they can measure exactly how far the stars moved during the event. Measuring that precise displacement allows astronomers to calculate the star's velocity, the final piece of data required to weigh that 20-year-old frozen world. Modern astronomy has become an act of multi-generational foresight, setting precise traps in the present to catch discoveries in the future. Look again at the full image right now. Try to comprehend the vast scale of what is in front of you. These are not camera artifacts. Every speck is a sun, many of them functionally similar to the one that warms our own sky. Scientific consensus suggests that almost every one of these 60 million stars hosts at least one planet of its own, circling out in the cold. This frame is barely a sliver of a galaxy that contains hundreds of billions of stars in total. We have not found life on any of these worlds. We may search for our entire lives and never find it. But sit with the sheer number of suns in this photograph and ask yourself, honestly, whether it is statistically possible that every last one of them is barren.